this thing's going every 2 or 3 minutes. It'll rake it up, scrape it up, drop it in the back, which is called the washer compactor. And there's blades in there that beat the stuff up, sprays water, tries to wash the organics out. We want the organics back in the system, not in the landfill. Okay, so if you want to come around the backside,
every 2 minutes. Right there as it comes out the top. Okay, removing that.
That's the washer compactor. Drop it in there.
Big side wash press.
Motors, right? So there's the upper drive, and then it pushes it down to the lower section. After you're over here, and then it pushes it out of that chute into that grit box we call it. That is completely self-contained. Well, yeah, you gotta take it apart. There's access plate. You gotta take it off. And the grit removal section. Vista-Grit is outside. We have pumps in the basement, centrifugal pumps. That will pump it up through this pipe here. Then it goes through the vortex, which separates the water from the grit. Some of the water and grit enters this screw conveyor right here, and then puts that into the grit box itself. So you can see that falling out the front side.
Right here. And in there. Stuff off the screen here. And grit coming off there right here.
This thing goes off of flow, so it's looking at the flow rate, and every certain amount of gallons it takes a sample. So then the sample is equal based on the flow, so it's not weighted more towards the nighttime flows or anything like that. So per, every, how many thousands of gallons, it'll pull 100 mLs or whatever and put it in there.
And then this is what's called
this is, we do VODs 3 times a week here. Yeah, the lab does all that stuff, but we don't do that. Comes back here, through this gate, goes through the Vista-Grit, which is that unit right behind you over here. There's a big circular tank buried underneath there. Blades are turning. It flings all the heavier stuff to the outside, which they then settle to the bottom. Right? We pump it off the bottom, it goes into the grit separator. Go through there, back through here, sample, and then it goes down to our primary clarifiers. These are rectangular clarifiers down here. You guys know the difference. There's a circular type, which is the older style, and then they tried making these rectangular ones to save space. Right? They don't work as well.
What's the name of that sucker there?
That's the Vista-Grit. Yeah, so that's where the flow goes in there, and there's a big paddle in there turning around, and all the heavier stuff goes to the outside by centrifugal force, and then settles to the bottom.
So it further refines it.
Yeah, we're removing rocks, rocks and diamond rings and all that stuff. Right here, that's the flights on the bottom that are dragging the sludge back. Okay, so they're moving real slow, just dragging it back. Directly below us here is the sump where all the heavier sludge ends up, and we pump it out to the digester. Okay, so at the far end is where our grease removal system is. It used to be up in the front end, but obviously with the flow going that way, it was a hard time getting the grease out. So they did a modification where the grease removal is now down at that end, which doesn't seem to work much better.
Oh, okay.
Yeah. Filament.
Yeah, that getting fogged. We get you every time.
Yeah, so I don't know if you want to see that.
Flow's going this way, away from us here. So it comes down here.
Depending on how much grease we're getting in, if we're seeing a lot of buildup, we decrease the timer. Generally it runs 30 to 40 minutes until it cycles. Every 30 or 40 minutes this will come on for a minute. Yep, Franklin's got a grease filter. Okay, so then after this trough fills up, we have progressive cavity pumps down here that pump it back up there. So there's a receiving area up there for it, which then that fills up, and then we pump that to the digester. So I don't know if you guys have seen But you can see it. So these are the progressive cavity pumps right there. I don't know if you're familiar with those. But they have like a corkscrew looking rotor in there that turns, and then the cavity kind of matches it, so it's a positive displacement pump.
Skimmer right here at the end of the primary clarifier. Sends it back up, accumulates over there, then over to the digester. See right here the beautiful scum skimmer panel here.
See these white pipes right here, and there's that big pile of bark chips back there, right? So we have some fans that are pulling the foul air off the weirs underneath these metal things. That's where all the weirs are. So it's pulling air off of there and pulling air off of all the influent channels and the headworks and blowing it into that pile of chips. There's pipes underneath there with diffusers. So all the foul air is coming up through the chips, which will keep wet. You can see the water going on it. And there's microbes in the chips that live off of the sulfur and all the foul air stuff. So that's how we clean our air and keep it from smelling a lot. Instead of having like a carbon scrubber or chemicals or something like that, we just use biological filtration.
How often do you need to, you ever have to replace the chips?
That was changed out
Comes up from underneath the bark?
last year. I think it was 10 or 13 years old, something like that. The lifespan, the expected lifespan is like 5 years, and we ran it for twice as long. But there was a lot of compaction, and you know, things broke down, so it was real just like forest dirt at the end of things. You know, real broken down. Yeah, you know, I wouldn't put it in my
plastic ones for you.
Air removal system here, and you can see they push it up through with the headers and onto the bark chips that they keep wet, let biological treatment remove some of the odoriferous air, sulfur content.
It comes over to the aeration basin. It actually enters down at that side down there where we measure the flow again, and then it'll serpentine through all these basins. The first 3 basins are anoxic zones where we're not adding any air, right? So it's got low DO, we have mixers in there keeping it stirred up, flows through there. That's to help control the filamentaceous, or the filaments, right, which create the foam. We don't want foam. So it serpentines through here. We control the dissolved oxygen to anywhere from 1.5 to 2.5 are our general set points. 1.5 when everything's running good, we're trying to save energy, right? 2.5 when we're having filament issues, we'll raise it up. So it looks pretty good today. Doing its thing. This is where we're oxidizing all the BOD. So general detention time through here is anywhere from 2 to 4 hours, depending on flows. Right now we're probably around 3 hours. Okay? So also what's going through here is the return activated sludge. So when it leaves here, it goes down to our secondary clarifiers, settles out, and then we have pumps that will pump it back up to meet up with the influent. Okay, and in general, it's about 50% of the influent flow will be RAS flow as well. So it'll be 2 parts influent flow, 1 part RAS flow. So 1/3 of it, I guess. Activated sludge process, yeah.
Conventional activated sludge.
What's that? It's plug flow. Yep, so it just serpentines through all the basins and then goes out right over there. So we'll go in this building here. I'll show you guys the blowers throughout the plant.
Nice.
Right, so you can see our blowers running here. You can see pretty much everything you need to see on this. Right, there's the primary clarifier. Right, you can see the biofilters. Not much to see there. But this thing, not everything is controllable through this, but a lot of things are. As far as set points, pumps on and off, that sort of thing. Some things still are manual where you got to go turn it on. But there's that. We have blower controls. Here's all our electrical stuff for the upper aeration basin and secondaries. Here's the blower. Sorry about the water here. We're running one blower. We can run it set up with two blowers. One is a lag, but we don't do that. That's for power saving.
Power saving by running one blower. Blower rooms right here. 2 and 3, these are where the air comes from in the aerobic digesters out in the activated sludge process.
Coming in the very center, and it has to go underneath that baffle, and then out through, right, and then overflow the weirs. The RAS comes out right here. This is a little bit strange. It doesn't have draft tubes. The low plant will have draft tubes for the RAS. I don't know if you're familiar with that. This one actually has, there's the sweep arm there, and mounted to the bottom of it is a pipe. That's just like vacuuming the bottom, getting all the RAS. Putting it over in this pit over here, and then we pump it back up. Down below, we'll be able to see the draft tubes, which is the older style. Okay, so 2 million gallons of water right there.
2 MGD secondary clarity.
How long does it take for the arm to go? That arm's probably half hour. Half hour? Yeah. It's a long time to be waiting for it. Yeah. So we can go in the digester next, since we're right here. Unless you guys want to see the, we'll just follow the flow. You want to follow the flow or see the digester?
Follow the flow.
The aeration basin here. We're able to take a look at. There we go. Yeah, we generally keep them full of water, partially to keep the UV rays from damaging the diffusers. Now, does anyone know what kind of diffusers these would be?
Air diffusers?
Same one as at Vancouver. Yeah.
These are fine bubble diffusers, as opposed to coarse bubble. They're much more efficient. These were installed 2 years ago, part of our energy upgrade stuff. So, lots of diffusers, right? That's just what the other ones up top. The first cells will have them twice as close, because you need that much air to initially get the DO up. But we generally don't run this basin.
Chlorination right here. Good mixing.
You run generally about 1 ppm chlorine residual.
1 ppm.
Okay, so the lower plant flow and the upper plant flow. So lower plant's coming in here, upper plant's coming in here. We're hitting it with a chlorine dose right here. Flash mix. Then it goes into either one of these chlorine contact chambers. Right, we're required to have 20 minutes of contact time. Generally, it's anywhere from 30 to 40 minutes through here, unless we're having real storm flows. We've been flowing about 12 million gallons on average lately, a day. 12 million a day.
What do you use for chlorine? Gas or liquid?
No, we use sodium hypochlorite 14.5%.
And dechlorinate with?
Sodium bisulfite. Thumbs up. That's how they built it. It's also, so they just redid a bunch of it with clear cedar, but all the rest of it that you can't see is all part redwood.
Okay.
Which they pulled it out of here. It's been in here since the 80s, and they still, the only parts that were rotten were above the water line. Just kidding. Yeah. Yeah, so it's like an old log sitting in the bottom of the river, doesn't ride.
Where we're coming out to the final end product of the flow.
So we flow from here to a structure on the other side of the track where we measure flow. We're dechlorinating it right at that point. We got pipe. Flows through here, mixes, and then we're reading, at this point, we're reading the oxidation reduction potential. The ORP is read right here. That's how we control our dose rate. So we ORP in the front end with the chlorine. Bring the ORP up, and then it goes to the mason, and then it hits these probes, and that controls the bisulfite pump. So as the ORP increases to the set point, the pump speeds up to maintain set point. Right, so chlorine raises the ORP, bisulfite brings it back down. Organic composite sample, so we sample the influence, we sample at the end of the primary clarification, and we sample at the end.
Influence sampling, and the primary clarifier, and effluent sampling.
Backing us up. So they move, we have another flume across the tracks, measuring flow over there.
Where's the flume?
There seems to be a 3-foot flume. Nice. And phosphorus tests and all that whatnot. And then we have our process lab in the back. Yeah. Yeah.
The lab here.
So,
BOD incubator. Coliform incubators. Drying ovens. Stock everywhere. Eppendorf pipettes, micropipettes here in the lab. Here's the muffle furnace. Oh, looks just like our little COD reactor. Autoclave. We're getting there. Oh, that's what we're talking about. LDO. Ports here for filtration. Here's that. Oh, look at that one. HQ40 here.
this is what was on the